Hello, Dan here from Genetec's technical training team, and today I'm going to do my best to introduce you to Security Center's architecture. So in this lesson, we're going to take a high-level overview of what we call role-based architecture, which is really the fundamental building blocks of a Security Center system. Then we'll have an overview of video architecture, access control architecture, and ALPR architecture. Because ultimately, Security Center doesn't just live by itself, but it's used to manage video hardware, or access control hardware, or ALPR hardware. So let's begin. The Genetec Security Center server, or servers, are an essential part of your Security Center system. What is it exactly that the Security Center server does? A Security Center server essentially manages hardware and serves information to software clients. For example, IP cameras need someone to tell them what frame rate to use, what resolution to produce, where to send their video stream. The Genetec server does this. It acts as the boss of the cameras, telling them what to do, and it also records their video streams and serves some of those images to software clients. Those software clients could be a security desk application running on a PC, could be a tablet or a smartphone app, or a video display wall. The server manages hardware and serves information to software clients. Genetec server architecture is based on the concept of role-based architecture. So what does that mean? What is role-based architecture? Many versions ago, we used to use service-based architecture, like so many other solutions out there. In service-based architecture, we installed different Windows services on our servers depending on what we need the servers to do. There was a Windows service to manage cameras, another Windows service to serve maps, another Windows service to manage doors, etc. Everything we needed the servers to do was packaged as a different Windows service. Well, this means that every server is running different software. Years ago, we abandoned that model in favor of role-based architecture. Role-based architecture is the foundation of Security Center's server architecture. Role-based architecture means that every server has the same software: Windows, SQL Server, and the Genetec Server Service. It's one of the foundations on which our failover and redundancy features were built. It really boils down to the concept that from a software perspective, every server is the same. And if every server has the same software, then in principle, any server could do the work of another server. So we're not really going to get into the nuts and bolts of failover, but this notion of every server having the same software is really at the heart of it. Now, if I'm managing a multi-server system, part of my job as an administrator is going to be to assign server roles to the Genetec servers. These roles run within the single Genetec server service. There's a role to manage cameras, a role to manage door controllers, a role to manage connections to other Security Center systems, etc. There are many different server roles available depending on what you need the system to do. Maybe a couple of dozen in total. The important concept here is that all roles run within the Genetec server service. So as long as we install the Genetec server service, we can run any role we want on the given server. This illustration is showing a 3-server system where the administrator connects from a workstation using the config tool application and deliberately assigns specific roles to specific servers. Those icons you see on the servers represent the different roles. Here are the most essential core roles used in Security Center. First of all, every Security Center system needs a directory role. If you don't have a Genetec server running the directory role, then you don't have a Security Center system. It doesn't matter if we want to manage cameras or doors or license plate readers, every system must have a directory. The directory is where all system configurations are saved. The directory is also the central connection point used by clients to connect and log in. Next, the archiver role. If you want to manage cameras, you must have an archiver. It connects to the cameras to tell them what to do, and it records or archives their video. Next, the access manager. If you want to manage door hardware, you must have an access manager. It pushes our access logic down to the hardware and listens to events coming from the hardware. Events like access granted, access denied, door forced open. Not only does the access manager listen for door events, but it writes them to a database so that we can generate reports. And lastly, the LPR manager. The archiver manages video hardware, the access manager manages door hardware, and the LPR manager manages license plate recognition cameras, or more specifically, AutoView Sharp cameras. The LPR manager pushes our configurations into the Sharp cameras and receives license plate reads from them, which are then written to the LPR manager's database. Here are some of the other server roles that are commonly found by default on most Security Center systems. Now, we've already discussed what the roles on the top row do, so let's look at the bottom row here. The health monitor monitors system health events and writes them to a database. Health events would include things like packet loss, CPU high, server storage full, hardware device offline, things like that. These health events can be used to generate live alerts or generate historical reports. The map manager. This is the server role that serves graphical interactive maps to connected clients. There are more and more end users who prefer to monitor their security system by looking at a map, maybe a floor plan of the office, with icons indicating the positions of our cameras and doors. Well, this is the server role that serves those maps to connected clients. The report manager. The report manager allows us to automate the running of reports and the printing, saving, or emailing of those reports based on schedules. The zone manager. This is used to monitor inputs and control outputs on various hardware. Door hardware can have general purpose inputs and outputs. Camera hardware can have general purpose inputs and outputs. Let's say, for example, we wanted to connect a PIR motion sensor in an office corridor to an input on one device, and the hallway lighting control on the output of another device. The zone manager who monitors these inputs can be used to turn on the hallway lights whenever motion is detected. It also uses a database where it writes all the input and output events. And lastly, the web server. It serves some of the security desk tasks to web pages. This means that clients can connect using a browser instead of installing the full security desk application. And there are many, many more optional roles. Using the config tool application to create a new server role and assign it to a server depends on what your license supports. So some of us might find more available roles and others might find less. Role-based architecture offers us 3 advantages over traditional service-based architecture. 1. Installation of a big multi-server system becomes much easier. Imagine if you're the technician assigned to the server installation for a big airport project, and that project requires 25 servers for their massive security system. Well, with service-based architecture, I would need a very detailed work order itemizing exactly which Windows service needs to be installed on which server. But with role-based architecture, easy, they're all the same. The administrator will configure their roles or their specific workloads later. Well, actually, they're not really all the same. In this world of role-based architecture, all servers are equal, but really one is more equal than the others. It's called the directory server or the main server. So if I install a 25-server system, the only thing I need to know in advance is which one will be the main server. After that, they're all the same. 2. Maintenance of a running system becomes easier. If I need to upgrade the RAM on my report manager, for example, I can simply move that role to another server, take the initial server offline, do the hardware upgrade, bring it back online, and then move the report manager role back to its original server. When all servers have the same software, you can move roles around from one server to another. And 3, scalability. What we're really describing here is really the underlying architecture for any large grid computing or cloud computing platform. Most massive cloud computing systems are made up of many individual servers, all running the same software and configured to work together. Well, that's what role-based architecture does too. We just use different terminology. This is an architecture that supports much larger scales than the traditional service-based architectures. So role-based architecture is the first concept to grasp when we look at Security Center architecture. And here's the second defining aspect of Security Center's architecture. It employs an open architecture model. Open architecture means that we intentionally want Security Center to be compatible with as many hardware, software, and infrastructure integrations as possible. We don't want to tell you what kind of cameras or door hardware to buy. We want you to choose, and Security Center should support it. So what? Doesn't every security platform allow you to choose your own hardware? No. Most security platforms are designed and developed by hardware manufacturers whose core business is hardware. Cameras, door controllers, intrusion panels. Of course, it's normal that they will design their software specifically to support their own hardware. You can't use a Pelco camera in a Sony video management system, for example. Just not supported. In fact, Security Center is one of the few remaining open architecture platforms on the market today. Now, that doesn't really mean that we support every single IP camera and door controller in the world. Our supported devices list is indeed finite, but the goal is to support as much as we can. And with every subsequent version that's released, you'll find that the list of supported devices grows. And this concept of open architecture extends beyond just the hardware integrations. We use the same approach to integrating with other software systems, using our SDK, and supporting different kinds of infrastructure components. Okay, so let's zoom in from that high-level discussion of our role-based server architecture, and we'll look more specifically at the architecture of our video, access control, and license plate recognition platforms. We'll begin with a look at our video architecture. What is the absolute minimum required for server roles if we want to manage video in a Security Center system? First, we'd need a directory. Every system needs a directory, regardless if it's a video system, access control system, LPR system. The directory is where the client applications will connect, and it also keeps the system configuration database. Secondly, we'd need an archiver. This is the server component that connects to cameras, tells them what to do, and records or archives their video streams. And third, we would need a media router. The media router is the server component that understands our network topology and manages video stream redirection. Without it, the archiver would be able to record cameras, but clients would never be able to see the live video streams. Basically, we use the media router to manage streams that need to be sent out to clients. Now, we might have more server roles running, especially considering that some of them are there by default, but what I'm saying is, as a bare minimum, we would need a directory, an archiver, and a media router to manage video. Now that we've discussed the critical server roles for video, here are some additional video server roles available. The Kiwi Vision Manager and the Kiwi Vision Analyzer roles are used to perform video analytics. We won't get into what's the difference between the Kiwi Vision Manager and Analyzer in this training. Suffice it to say that they're both required to perform video analytics. The Media Gateway serves Security Center video streams to web clients, mobile clients, maps, and third-party systems outside of Security Center. Let's say, for example, that I work for the city as part of a traffic management team, and I wanted to publish some of my highway cameras to the city's website so that residents could have a look at the traffic from a web page. I could use the Media Gateway to share specific video streams with other applications, like a web server. And lastly, the unit assistant role. It is in fact a default role, so it's not really extra, but we haven't discussed it yet. What the unit assistant role does is it manages its own encrypted database in which it saves usernames and passwords for the various hardware devices, in this case video units or IP cameras. The unit assistant role allows us to push password changes into our hardware devices, our cameras, automate the password changes and schedule them to be run in batches to cover multiple cameras, view and export cameras' passwords from the hardware inventory task, generate random secure password strings. So it's not really a critical role in that sense that if the unit assistant role crashes, we can still work with video, but it is a default role. The archiver and its cameras. The archiver, one of the critical roles to manage video, reaches out and connects over TCP to each one of its assigned cameras for the purpose of exercising command and control. It receives live video streams from each camera, it saves the video frames to its storage, or it archives or records video, and it indexes video events in its SQL database. Video events would include things like motion detected, recording started, recording stopped, bookmark added, RTP packets lost, and even analytics events generated by the camera's own video analytics. Every video event written to the database includes a pointer to the video file saved in storage. We use the archiver's database when searching for recordings. Our searches are not actually done on the recorded video files, but they're done in the SQL database. We run a search, get a list of results, and each result links to a recorded video file. In the case of database corruption or other SQL problems, there's one single search task that doesn't query the database but acts more like a video file browser, and it's actually called the Video File Explorer task. And here's our default live video streaming architecture. Now, what I'm about to explain here is the default. Alternative streaming architectures can be used, but this is how it works out of the box. The camera sends its video stream to the archiver, and for the large majority of today's IP cameras, that would be an unencrypted stream. There are, in fact, very few cameras on the market today that offer encryption right in the camera itself. The archiver receives the video stream, and if it's been configured to record, it writes the incoming video frames to storage as the recording. Now let's say that a client application double-clicks the camera icon to request the live video. Well, the archiver hands the video packets to someone else who lives inside the same server, the video redirector. A video redirector is not part of the archiver, but it's a separate component. On every server where an archiver is created, we also create a video redirector. And its job is to redirect the incoming video stream to client applications. By default, this is done with a unicast UDP transmission. That means if one client wants to view the video stream, the redirector sends one transmission to that specific workstation. But if 2, 3, or more clients all want the same camera, the redirector sends each one of the clients their own unicast UDP transmission. And that's the default streaming architecture. If we want, we can configure the system to stream directly from the cameras to the client workstation, or we can force video redirection through multiple servers, multiple redirectors. So alternative streaming architectures are supported, but I'm showing you the default behavior. What about pushing configurations into the cameras? As a system administrator, I connect using my workstation and I apply something like 15 frames a second VGA resolution to one of our cameras. The camera would then start generating a stream of 15 frames a second using VGA resolution. But how exactly did that happen? My laptop is not connected to the camera, and someone or something actually has to push those settings into the camera itself. Well, my workstation is connected to the directory. That makes sense. The directory is where all of our system's configurations are saved. But the directory isn't connected to the camera either. So it pushes the setting to the archiver, who may or may not live inside the same machine. And the archiver is actually connected to the cameras. So it uses its TCP connection to push the setting into the camera itself. And it's for this reason that once a camera is connected to a security center system, we ask you to stop using your camera's own web page to change settings. Instead, you should have any camera configurations pushed from the Genetec server. The archiver and playback video. In a big system, we might have many cameras across multiple archivers. Each archiver has its own storage and its own index of recordings in its own local database. So if I'm looking for a specific recording from a specific camera, how is that done? The workstation doesn't know in which archiver the camera is connected to, so the workstation doesn't know which database should be searched. Well, the client workstation is connected to the directory, and the directory knows which archiver the camera is connected to. So when a client requests recordings from a specific camera, that search is actually an SQL query that's forwarded to the archiver who records that given camera. The archiver queries its local database and replies with a list of available recordings. The client then chooses a recording from the list, and the archiver sends the playback stream to the workstation. So this concludes our initial overview of video architecture. Let's look next at access control. Let's begin by looking at the door hardware. Managing physical access is usually done by using hardware devices known as door controllers. Door controllers consist of some inputs, some outputs, and a network card. A door controller, or one of its interface modules, will be physically wired to components at the door itself. Typically, we might find a reader wired to one of its inputs, a lock wired to one of its outputs, a door sensor wired to another input, and perhaps some other device like a request for exit button wired to another input. The access control logic is saved on the Genetec server and then pushed into the door hardware by the access manager role. What is the absolute minimum required for server roles if we want to manage doors in a security center system? Well, first, we need a directory. Every system needs a directory, regardless if it's a video system, access control system, LPR system. The directory is where client applications will connect, and it also keeps the system configuration database. Secondly, we'd need an access manager. This is the server role that manages our access logic and listens for any door events. Those events are written to its SQL database. What we see in this illustration is that there is an intermediary between the access manager role and the door hardware, a Synergis cloud link. This is the Genetec appliance that connects to many different types of door hardware and pushes our access logic into them. Now, we might have more server roles running, especially considering that some of them are there by default, but what I'm saying is, as a bare minimum, we would need a directory and an access manager. The access manager connects to each Synergis appliance, who in turn is connected to the door hardware. It pushes our access logic down through the appliance to the door hardware. It receives door events from the door hardware. And it maintains a database of historical door events so that we can generate historical reports. Something worth pointing out in this illustration is that our quest for open architecture happens at the server level for video units, but at the appliance level for door hardware. It's the Synergis CloudLink appliance, not the access manager role, that connects to, talks to, and manages all the different kinds of door hardware. And we can see in this illustration a mix of iStar, Axis, Mercury, and ASA Abloy door hardware, all being managed by our CloudLink appliances. So that concludes our overview of access architecture. Let's move on to ALPR, or Automated License Plate Recognition. For AutoView license plate recognition to work, what are the bare minimum server roles needed? First, we'd need a directory. Every system needs a directory, regardless if it's a video system, access control system, LPR system. The directory is where the client applications will connect, and it also keeps the system configuration database. Second, an LPR manager. This is the server role that connects to the specialized ALPR cameras to push our configurations and settings into the hardware, and it also listens and receives plate reads and plate images from the specialized hardware known as Sharp cameras. Lastly, we need an archiver. But isn't the archiver a server role used to manage video streams and images? Yes. While the LPR manager records the values of the plates read in its database, the images themselves are sent to the archiver for storage or recording. So again, Sharp units are the specialized automated license plate recognition cameras. The LPR manager is the server role that is their boss. It connects over TCP to each Sharp unit. It pushes configurations like regional context to the Sharp units. It receives plate reads from the Sharp units and stores the plate value in its database while forwarding the plate images to the archiver for recording. And it keeps hot lists, or lists of plate values of interests. Whenever a plate is read, it's compared to a hot list to determine if there is a hit. ALPR projects can be set up in fixed or mobile configurations. Fixed ALPR means that the Sharp unit doesn't move. It might be mounted on a pole at the entrance to a car park, and it just reads the plates of all vehicles entering and exiting the parking lot. That's a fixed installation. But there are also mobile setups. For a mobile installation, the Sharp unit is moving. Typically, it'll be installed on the roof of a police cruiser or a parking enforcement vehicle. Then, as the vehicle drives through the streets, the Sharp unit will read license plates as they move. A mobile installation uses one additional component, the patroller. Often, mobile installations means that the Sharp unit will not be connected to the LPR manager server role. The patroller is the software that runs in the vehicle itself. It receives reads from the Sharp camera and saves them locally. It cross-references plate reads to its locally saved hot list to determine if there are any hits. And eventually, when reconnected to the rest of the system, it offloads all plate reads, images, and hits to the LPR manager for longer-term retention. In a small single-server system, everything runs on one server, the directory, archiver, and LPR manager. But for stability and performance reasons, we recommend creating two archiver roles within that single server and using one archiver for video recordings and the other archiver for license plate images. And in a bigger multi-server environment, the same principle applies. While the recording of images from security cameras and from Sharp units can all be done on one archiver, the best practice is to dedicate an archiver to the LPR manager and to use a different archiver for the recording of video streams from security cameras. This concludes our overview of ALPR architecture, and this concludes our architecture mini training. Thank you for attending.